So hello, my name is Brian Thomas. I'm here today to kind of do a little bit of GD in review for math. This first topic, we're going to kind of do number sense. Again, the GD itself in math, it's really about your reading and comprehension because again, the test itself is called math reasoning. So your ability to read and comprehend is very, very important. The other part of it is your ability to actually know a bit about the relationships in math. So without further ado, I'm going to kind of start working and showing you some strategies of how to go about taking the GED math test. When you're working with word problems, there's going to be what we call knowns, and then there's the unknowns. Then there's the relationship between the knowns and unknowns. Also, you can actually sometimes do an estimate to help reason out the problem. You may have to actually set up and solve the problem. And again, on the GED test, most of the tests you're allowed to use a calculator. Once you do set up and solve it, always make sure your answer makes sense. So those are kind of going to be the tools to help us kind of navigate these word problems. So as I do these, feel free to pause the video and work ahead of me and see if your strategy um, can answer the question. Because again, there's more than one way to solve these problems. Um, so what I'm going to focus on are just trying to be consistent and stay with uh, the strategies that I've listed. So again, the first thing is you kind of see we have a little short word problem here. When you read it, take your time reading it, pay attention to the pauses and things like that and try to absorb the information as you read it. That's the hardest part. It is a time test. A lot of people want to read really, really quickly, and then you're stuck with rereading it again. And again, read it as many times as it takes to um, try to understand the problem, and then you can kind of start piecing it together. Also, as we move through it, you'll start to pick up on some word clues as well. So this first one, a healthy beverage container holds 12 servings. If the serving size is 8 ounces, then how many ounces does the container hold in all? Okay, so there's our problem. So again, if I look at, picking up on the knowns, what we see is we have a container that holds 12 servings. So from that perspective, and again, I'm going to kind of draw things out a little bit and show a little bit of my thinking. You could have this container, doesn't have to be perfectly drawn. And this container inside of it has, 12 servings. So that's what we're kind of picking up on the beginning is you have this big container. And then a serving size, so a serving size means one serving is 8 ounces. So 8 ounces is basically like the little serving. So those are 8 ounces. So those are different measurements. So it's 12 servings, and that is 8 ounces per serving. And then the question says, how many ounces does the container hold in all? So I got to remember over here, this is actually servings. I'm just going to abbreviate that, 12 servings, and I have these 8 ounces per serving. And again, I'm looking for how many ounces does the container hold in all. So the unknown is this last part, how many ounces? We don't know total ounces because we use that word in all. So again, you don't have to necessarily be writing this down, but that's your mental notes to this problem. I'm looking for the total ounces, so I'm kind of jotting some information down. So the relationship that I'm picking up on is, there's something to do with servings, and somehow that's going to help us work with these ounces to get one of these answers down here. The key here, though, is they don't really say, but the serving size, that means one serving. So what I pick up on is if one serving is 8 ounces, then and there's 12 servings, the relationship that I'm picking up on is, I'm going to just multiply 8 times 12, and that's going to tell me my total amount. So that's the relationship I'm picking up on. Is if one serving is 8, then 12 servings, I'd just be multiplying that by 8, and that would give me my total servings. Now, as an estimate, you could round 12 to say 10, and 8 times 10 would be like 80. So 8 times 12 has got to be above 80. So that's kind of leaning me towards D as an answer, this 96 there. Now, if I want, I go ahead and use the calculator here. So if I go ahead and do 8 times 12, that does give me then that 96. But an estimate will do just as good. So we pick up on then that we're getting this 96 as an answer. So 96 ounces all together. And that kind of does make sense in this problem here. So I feel pretty good about that answer. So see if we can move on to another question. So the next one we have is Mitchell bought a used car with 39,451 miles on it. If the car has now 70,040 miles on it, how many miles has Mitchell driven the car? So again, feel free to pause the video and work it on your own, and we kind of meet on the other side of this. So we do see some numbers here, but understanding what those numbers mean. So Mitchell bought a used car with 39,451 miles on it. So to me, that is his initial miles on the car. So 39,451 miles were on the car to begin with. His car now has 70,040 miles on it. And how many miles has Mitchell driven? So we also know that 70,040 is what's on it now. What we don't know is how many miles he's driven. So that's going to be the unknown. So how many miles has Michael or Mitchell driven? So what I pick up on is the relationship is I'm at 39,451 when I bought the car. So I'm adding some miles onto it, which we don't know how many miles that actually is. But we do know at the very end, though, I should be coming up with 70,040. So what we pick up on is, something added to 39,451 should give me 70,040. So what I can kind of pick up on is, this answer here and this answer here look way too big. So it's going to be either this answer here or this answer here. So what I could do is add those to the 39,451 and see which one actually gives me the 70,040. I can also work backwards. And if I work backwards, that would tell me to actually subtract. So a couple ways of doing that. I can actually substitute these answers in to this relationship, or I can actually subtract these two numbers, and that'll tell me what Mitchell has driven. So I have this 70,040. Make sure you type that in correctly. That's a tricky little number. Minus then the 39,451. If I hit enter, that gives me that 30,589. So it looks like A is going to be the best choice there in this problem. And again, that makes sense because 39,451 is where I'm at now. If I add 30,589, that should tell me how much I have in the end. So if I wanted, double check that, I could. Let's see here. So if I'm at 39,451, if I add to that the 30,589, hopefully that does give me the 70,040. So it does check out. Okay. So this next question, again, you feel free to pause it before we move on. Avery paid 20% of $3,280 as a down payment. How much was his down payment? So this is a percent problem, and a percent is kind of like fractional math. Percents kind of represent a portion. Avery paid a portion of $3,280 as a down payment. How much is his down payment? So the knowns is this 20% down. That's the portion that he put down. And we do know that the whole amount was this 3,280. So he didn't pay the whole 3,280, he only paid a part of it. So the relationship is a little tricky still, but based on an estimate right now, I can kind of rule out D because he's only paying a portion of the 3,280. So I'm down to really A, B, and C as answers. Just thinking as my estimate there, I have to be under 3,280. Now, one thing to pick up on in math though is, as far as the relationship goes in percentages, what I like to use is what's called the triangle model to organize my relationship with percents. In this triangle model, the part or the portion goes on the top, the whole amount or the base amount goes over here on the bottom, and then the percent goes over here. And what this triangle relationship tells me is that the portion and the base will be divided, and that will allow me to find the percent. If I divide the portion by the percent, that'll give me the base, and the base times the percent would give me the portion. So in this problem, what I'm picking up on is, if I draw my triangle again, that this portion is what we're looking for. We're looking the part that's being as a down payment. So the 3,280 is going to be what we call the base amount. And the percent is 20%, but we change that to a decimal by moving the decimal 2 places to the left. That becomes 0.20. Because remember, 20% means 20 out of 100. And 20 out of 100 is the same thing as 0.20 or just 0.20. So what I pick up on is, if I multiply the 3,280 times 20% or 0.20, that'll allow me to get the answer there. So see if I can find my calculator. Looks like I lost it. So 3,280 times 0.20 gives me then 656. So my down payment would actually be $656. Now, something else that some people know is, as a shortcut, sometimes we know that 10% is a shortcut one, where 10% means all you got to do is move the decimal 1 place to the left. So if I want to find like 10% of 3,280, 10% just means to lose 1 decimal place. So 10% would have been $328. But 20% is double that. So I'd have to do 328 plus 328, which would take us right back to the 656. So another strategy is, in percentages, is 10% is one that's easily done, because all you have to do is move your decimal 1 place to the left, and that'll give you 10%, which will give you a starting place for an estimate. So again, notice how we have the knowns were the 20% down, and the whole amount was 3,280. The unknown was the part, or in this case, the down payment. The relationship can be organized in a triangle model. An estimate like I said, we know it's got to be under 3,280, which allows us to negate the D. And also, we could use 10% as a way to get through to an estimate. And then as far as setting up and solving, I would be looking for the portion, which means the base and the percent would be related by multiplication to find the down payment. And that answer does make sense to $656. Okay. Obviously, you're going to go much quicker than that on the GED test, but I'm just trying to help you with some of the thinking at this time. So in this question, Sylvia can drive 180 miles in 3 hours. On Sunday, she drove for 7 hours. At that rate, how many miles did she drive on Sunday? So we know she can drive 180 miles in 3 hours. That's known. In 3 hours also can be per 3 hours, which means I can also write that as a ratio or a division problem. This is also considered a rate. So 180 miles in 3 hours or per 3 hours. So that's the relationship I'm picking up on between these two, is that is actually can be expressed in this format if I wanted to. Another thing we know is she drove 7 hours altogether. And what we're looking for is how many miles did she drive on Sunday. So we know it's got to be over 180 because in 3 hours she can drive 180. So 7 hours she's obviously going to drive more than 180. And 6 hours would be like what? 180 and 180 would be like, what is that? So if I double that, I could use the calculator. That's going to be 360. So I know that in 6 hours she's going to do 360. So 7 hours is probably going to be a little bit more than 360. So it looks like right now I can kind of rule out D and A, and B and C are the only ones left. So just by using a little bit of thinking. Now, what I pick up on though is, this is a rate, but I can make it a unit rate if I just divide this out. So if I divide 3 into 180, or I can just use a calculator, 180 divided by 3, that's going to be 60 miles in 1 hour. So I can also modify this where this is simply 60 miles per hour per 1 hour. So what that picks up on is if that's 60 miles per 1 hour and I drove 7 hours, my relationship now would be then 7 times 60. And 7 times 60, well, I can just do 7 times 6 is 42 and then add that 0. That's going to be 420. Well, you don't need a calculator for that one. So 420 miles would be the total miles that she drove on Sunday. And that's kind of is kind of fitting in with my thinking. So that's what we kind of pick up on. So here to start with, we have 180 miles in 3 hours. That is actually a rate, which I can write like a fraction. And also the word in can be replaced with the word per, and per implies division. And then we know that she drove a total of 7 hours. So that helps me knock out A and D just by looking at the answers. I then can also make this a unit rate by dividing it out. Then I can just kind of multiply by 7, and that would give me my total miles for Sunday. So that's kind of my thinking there. So on this next one, if Alex drove 299 miles on 9 gallons of gas, about how many miles per gallon did his car get? So again, we know he drove 299 miles on 9 gallons. And again, there's this word about. About means this estimate kind of comes into play. We can round a little bit. About how many miles per gallon did his car get? Well, notice like 299 miles on 9 gallons is again that ratio language. So I can write that as like 299 miles per 9 gallons, like that. And notice how we want to know is how many miles per gallon. So that really just means per 1 gallon. So really what they're looking for is a unit rate. Instead of 9 gallons, they want this to become 1 gallon. So my thinking is this really just needs to be divided out. And, since it says about, I could go just say 300 because 299 is close to 300 and 9 is close to 10. And I could go 300 divided by 10. In other words, 1 goes in 30, be 30. So it'd be 30 miles per 1 gallon. So that's kind of what's jumping out at me there is that. So again, 299 miles on 9 gallons, I'm clearly going to get a lot less than that 300 is not going to be a reasonable answer. 270 also seems to be a little high because we're talking about 1 gallon, you know. So really A and B are the only logical answers to begin with. My estimate, again, is all we really need. But if we wanted to do the whole math there, we could have also, since we got a calculator, you could have just did 299 divided by 9, and that would give us like 33.2 with the repeating decimal, and that would still have to be, of the choices, the closest thing to that would be B, 30 miles on 1 gallon. So that's kind of what we're seeing on that one. So again, our unknown is kind of a ratio or a rate, which I can write in a fractional form. That kind of helps us move along into the problem. So this next one. So use the following information. How much would a large pizza with 3 toppings cost? So we got this information here. A large 1 topping pizza is for $14, and then each $2 for each additional topping. So again, I want 3 toppings. That's the known, is the 3 toppings. Well, also is known that a large 1 topping pizza already costs 14. And again, there's already 1 topping on the pizza. And I just need 2 more toppings. So what I'm picking up on is in this problem, it's $14 for a 1 topping pizza. I'm getting 2 more toppings, which would be $4 more. Therefore, I'm seeing a total of $18 as that answer. That one came together rather quickly where the process was really fast in my head. The knowns are here. A 3 topping pizza, how much does it cost? Well, actually, that's the unknown. How much does a large pizza with 3 toppings cost? What was known was a large topping pizza, a large 1 topping pizza was 14, and then each additional topping was $2. The catch is I just need 3 toppings. It already came with 1, so I just needed 2 more toppings. So that would give me my 4, and there's where that 18 comes in. Okay, that one can trap you into picking something else, so you got to really read that one carefully. That's what you have to watch out for sometimes. All right, so this concludes my GED review and just some number sense questions. Hopefully you'll find that useful.